Okay, so this is a little tree diagrams tutorial to help you with the Year 13 Maths Chapter 2. I'm just going to go through an example of some of the types of questions that can come up. One in particular that is different than what we'll have seen before and can be a little bit confusing initially. So I've got an example that we're going to look at. It's just counters in a bag, the usual kind of setup of a question. And the first part is to draw the tree diagram. So we've got 6 red counters, 4 blue counters. They're being taken out one after the other, so there's no replacement. So if you want to pause the video and draw the tree diagram, then I will show you what I get. I have used, if you want yours to match, I've used R1, R2, for the first counter being red and the second counter being red, and I've used B1 and B2 for the first counter being blue or the second counter being blue. And I've also used the conditional probability notation. Okay, so hopefully you've had time to do your tree diagram, and this is what I get for mine. So I've got the first counter being red, probability of that is 6/10, first counter being blue, probability of that is 4/10. I haven't cancelled any of my fractions down. The reason for that is so that I have absolutely no chance of messing this number up. If I cancelled that down to 3/5 and I was tired and I've done a lot of maths today, I might accidentally put 2/4 here, for example. Never cancelling your fractions down on a tree diagram would avoid that mistake. Okay, so I haven't cancelled any of my fractions down. You can if you want to, but you just need to make sure yours are equivalent to mine. So then we're given some questions. The first question asks for the probability that the second counter is blue, given that the first counter was red. Okay. Now I've put this in because it's actually quite often answered incorrectly. It would only be a 1-mark question. It wouldn't require much effort because it's a 1-marker, but people still get it wrong. People think that they're being asked for the probability that the first counter is red and the second counter is blue, and that's not what it's asking for. Second counter being blue, given that the first counter is being red, is just asking for us to write down this probability here, this 4/9. This is the probability that the second counter was blue, given that the first counter was red. So all we need to do is read this number off on the tree diagram. And that's quite a common 1st-mark question in exam situations. So just be aware that that might be what it's asking for first. Part 2 then asks for the probability that both counters were red. Okay. Now, to answer questions like this, you will have done these questions at GCSE. You may be thinking, yeah, it's just, this and this. But I'm going to answer it using that formula that we've learned in lessons, just to solidify it and to be really, really thorough. So, both counters are red. What we want to do in any probability question is try and make the question say and, or given. We made the first question say given. I'm going to make this second question say and. So that's the same as asking for R1 and or intersect R2. The reason we can then, we want it to look like this is because then we can use the conditional probability formula, which says the probability of A intersect B is equal to the probability of A times by the probability of B given A. So if we match this up here, we've got A for R1, B for R2. So we can say that the probability of R1 intersect R2 is probability of R1 times by probability of R2 given R1. And again, I know you can just go and get that from the tree diagram, but I think it's worth seeing it written like that. That will help us with part 3 and thinking about part 3. So from the tree diagram, that's asking us to work out 6/10 times by 5/9, which is 30/90, which simplifies, if you want to simplify it, you don't have to 1/3. Okay, so then moving on to part 3, this one seems like it's being asked back to front, and that's why I've put this question in. We may be expected to answer questions like this, and we shouldn't panic. We should keep thinking about the conditional probability formula. So what's this asking for? This is a given. So if I put a little b here and a little a here, we're going to be able to work out what equation we want to have. So probability that the first counter is blue, given that the second counter was red, is going to equal, we're going to need to do the division version of this formula, which is the probability of A intersect B. So the probability that the first counter was blue and the second counter was red. So B1 and or intersect R2 over the probability of A. So that's asking what the probability that the second counter was red. Now that sounds really straightforward, but actually there's a few different things that could have happened for the second counter to be red. Don't need this anymore. So that's what we're kind of going to be thinking about next. How could I get my second counter to be red? Well, that could happen by either having the first one red and the second one red, or having the first one blue and the second one red. And that's what we're going to have as our denominator. Similar to the Venn diagrams, we've kind of got what we want over what could have happened, what was allowed to be possible under the conditional statement. So probability that the first counter was blue and the second counter was red. First blue and second red is going to be 4/10 times 6/9. So this is now blue 1 given R2 over these two things here. So red 1 and red 2, well, we've actually worked that out. That was 1/3. I'm going to write it as 30/90. You'll see why in a second. Or, so plus blue 1 and red 2, which actually is this again. Blue 1 and red 2. So if we work that out, that's going to be 24/90 divided by 30/90 plus 24/90. That's 24/90 over 54/90, which is 24/54. And you can leave your answer like that, or you can cancel it down. Both of those numbers are divisible by 6, so we can simplify that to 4/9. Okay, so the probability that the first one was blue, given that the second one was red, is 4/9. Just be aware of what I've done on this denominator. Just make sure you're happy with what I've done there. If you need to go back and re-watch my explanation, then please do so, because 2E, you're going to have quite a few questions where you have to think like this. Okay, so hopefully that was helpful to you. You should now be able to go and answer the questions from 2E. Okay, let me know if you have any issues.